Right, so good afternoon again, everyone. I
Good
had
afternoon, miss.
an appointment. It's a good thing that I put the time to 1 o'clock. All right, so I marked some of the work. Some of them I started and then I didn't bother. I don't like seeing lazy work, people. You need to, especially the fact that we're at the start of the topic, you need to be showing the steps. I don't want to see that you're multiplying A times matrix B, and the first thing I see is multiplication going on. I don't see where you place the matrix A beside the matrix B and then proceed to multiply. I need to see that. If you make a mistake, it's gonna be hard for you to track your mistake because you're doing the work shorthand. And these lines here that I draw, they're not for decoration. I want you to use them. All right, it makes life easier on you and me when I'm marking. So I was actually marking them while I was at the doctor. So if you see where I started marking your work and I didn't finish, it got a little busy, so that is why it is not finished. Okay, Michaela?
Yes, it's no problem.
Okay, so I think we have one or two new students. Welcome, guys. They're not from,
They're not from.
all right?
Oh.
I don't,
I
if they watch the recording, as they did miss the first two classes, but they need to watch the recording. But as for today, I don't know if you look at your work that I marked, Jalil, you're doing double multiplication, so you need to look at that. But we're gonna do some more multiplication today before moving on. So in the last class, we mainly looked at, oh, let us pray. Lord, thank you for today. Thank you for your mercies. We ask for your guidance once more. I ask that you bless these students, help them to be successful, not just in mathematics, but all the subjects that they're studying. Help us to have a productive class. Help my children to sleep until the class ends. Thank you, Lord. In Jesus' name, amen. Yes, my children are sleeping. Praise the Lord. All right. So yes, so in the last class, we mainly looked at multiplication of 2 by 2 matrices. So today we're going beyond 2 by 2 matrices. We're gonna look at multiplication of other types of compatible matrices. So that's what we did the last class. Okay, there it is. All right, so remember that two matrices cannot be multiplied unless they are compatible. And for us to be able to identify if they are compatible, we have to look at the order of the matrix, of each of the matrix. So for those who were not present last week and didn't get a chance to watch the recording, when multiplying matrices, excuse me, please. Hello? Yeah,
Miss, you're breaking up.
okay. Give me a moment, please.
Okay.
Yes, sorry about the interruption. Right, so just a refresher, or just to try and bring those who were absent up to speed. We're looking at matrices, and we're looking at matrices multiplication. So the first thing to note is that two matrices cannot be multiplied unless they are compatible. In order to know if they're compatible, you have to look at the order of the matrix. And the order is determined by the number of rows, by the number of columns. So we discussed that rows go across and columns go down or vertical. So this would be row 1, and we would have row 2. Each of the numbers in the matrix is called an element. All right, so in row 1, we have 3 elements. In row 2, we also have 3 elements. Columns go down. So in this matrix, we have 1, 2, 3 columns. And the matrix is named by the number of row times the number of columns. So it has 2 rows. So it's 2 by 3. 2 by 3 means that it has 2 rows and 3 columns. Matrix B over here, rows go across. It has 3 rows, the row 1, row 2, and row 3. And it only has 1 column. So this would actually be a 3 by 1 matrix. I hope that is clear. And if you have a question, feel free to raise your hands. All right. So in order for the matrix to be compatible now, the number of rows, no, the number of columns in the first matrix should be equal to the number of rows in the second matrix. So you can kind of line them up. 2 times 3, 3 by 1. I don't know what kind of writing that is. That's a 1. So these two numbers in the middle, when you line them up, should be the same for you to say, determine that, okay, these matrices can be multiplied. So the number of columns in the first one should be equal to the number of rows in the second one. So seeing that that is the case, we can go ahead and multiply these two matrices. And if you switch them around to B multiplied by A, they cannot be multiplied because the two numbers in the middle would no longer be the same. The order is very important. So let's clean this up. So the first thing that we want to do is to I already explained that just now. So please, step 1, if you're multiplying or adding, is to write what you're doing. So write matrix A beside matrix B to show us that that is what you're multiplying. That is step 1. Hold on. Anybody want to attempt this question on the screen?
Yes, miss. Miss,
Really sorry about the interruption, guys. Unfortunate that I have to take these calls at this time.
miss, I think I want to attempt the question.
Okay, do you need the whiteboard?
Yes, please, miss.
Mm, okay. More. Yeah, hold on. Sharing the whiteboard. Oh, all right, there it is. They made a mistake right here. Should be 2 times 4, right?
Yes, miss.
Right here.
Is that it, miss?
Not quite. You were on the right path and then you doubted yourself, I believe.
I did doubt myself at the
Yeah.
last.
These plus signs are still significant.
Uh,
So it's gonna be 4 plus 9 plus 8, 8 plus 15 plus 2. So I'll finish it. Thank you for attempting. All right, so this is I soon finish it. This is a 2 by, let me write it over here. 2 by 3 matrix, and that one is a 3 by 1. So these two numbers in the middle tell you that, yes, these two matrices can be multiplied. And then no, these two numbers at the end tell you what kind of matrix you should get in the end. So in the end, you should get a 2 by 1 matrix. And when we simplify this, 4 plus 9, 13, plus 8, 21, 17, plus 8, 25, you do end up with a 2 by 1 matrix. Are we seeing that?
yes, miss. That's what caught me. That's why I did have
Yes,
doubt
miss.
myself there.
So you thought that
Also,
because you started off with these 3 rows, 3 columns, that's what you should end up with.
Yeah, yes,
You say,
miss.
wait, no, let me get rid of this plus sign. But the two n numbers tell you what kind of matrix you should get. So you know, so you look at the two n numbers to know what you're working towards. And if when you finish working, you don't get that, then you know that something is wrong, something is off. Yes, Michaela, you were saying something.
no, miss, I was just shocked.
Okay. Any questions though?
No, miss.
No, miss.
2 students in the class or the others' mics are not working? And if you're back, if you,
Mr. Good, I would like to ask a question about the first step. How do you guys end up with the plus sign?
oh, okay. The plus sign is the rule. So in multiplying, you have to multiply corresponding elements to each other. So it's the first element in the first row multiplied by the first element in the first column. And you have to add it to the multiplication of the second elements. And if you have a next column and row, you have to add it. So once you're dealing with a different row and column, you have to add that part.
Okay, Miss, I understand.
Okay. So we're gonna do one. Any more questions? I'm hearing a mic. Don't know. Alana, you have sound problem. If you're having sound issues, you can send a message in the chat. All right, so back to the continue change. Back to the PowerPoints. So we separate rows from columns we separate rows in the first matrix, and if there were more than one columns, we would separate columns in the second matrix. All right, so we multiply first element in the first matrix by first row by first element in the first column. Then we multiply second element in the first row by second element in the first column. Then we go to the third element in the first row by the third element. So you have to multiply corresponding elements, and in between those corresponding elements, you are adding. That is what we have done right here. And as I show you, the end numbers of the two orders tells you what kind of matrix you should get. So I made a mistake right here, and I'm just seeing it. 3 times 3, and I have 6. So I was adding right there. So these are things that you have to pay attention to. When you finish your work and you feel nice, like, yes, you did it right and it's perfect, do it again or check it over just to make sure. Sometimes, if you have the time, do it again because you're right in your mind. I don't know, is your finger process faster than your brain, or your brain process faster than your finger? And so in your head, you think you have X, but you really write down Y. So that is why you actually need to check over sometime. Because you may have 3 times 3 equals 6 right there. And that should be 9. So I have to fix that shortly. All right, so let me check the chats. Okay, Alana. All right, so that should be 9 and that should be 21. Remember, I'm going to post it. What I do is just keep on adding slides to the same PowerPoint. So when I update the PowerPoint, I just repost it. So this will be uploaded. All right. All right, I want somebody else or everybody, in fact, 2 minutes. You can give me your answer. Yeah, you can tell me your answer. 2 minutes to do this multiplication or 3 minutes. I want everybody to attempt.
Miss 3 minutes.
3.5 minutes.
Yes, Miss 3.
4 minutes. No problem.
Even better.
Mhm. Everybody's finished? I say 3 hands raised.
I'm finished.
Yes, miss, I'm finished.
All right. I think I already have the answer on the screen. So let's see if if our answers match up. Who
Yes,
got it
miss,
right?
that's my answer.
Yes, miss, that's my answer.
All right, and I see Alana's answer in the chat as well. All right, so all the persons that answered, I don't think it's everybody, said they got that answer, so that's wonderful. And this particular one is very important because when we get to the simultaneous equation part, it's gonna come in. I know you're excited to learn the simultaneous equations aspect.
No,
I
no, miss, not really.
can feel the excitement. It's sarcasm, guys, but in a positive way. I do hope you will be excited. All right, so 2 more for practice before we move on a little bit further. So I want you to do these 2 as well. It's just for practice, for reinforcement, to see if we're really getting it. I done fast a while ago, so no need
Miss,
another
so
thing.
should we're supposed to do those two? Sorry for not raising my hand.
Yeah, so do those 2 now, and then we check the answers to see if, yes, everyone is on the right path. Where is my book? Yes, Jalil, you're finished?
Yes, miss.
All right. Let's give the others 2 minutes and see. All right, so 2 persons. All right, what's the answer that you got? What's the answer that you got for the first one, Michaela or Jalil? Both.
I
5-2.
got 5/5.
Mister got 5/2.
5-2. Okay.
Yes.
I'm interested to hear the answer for the second one.
Miss, why is that so
Mm,
complicated?
Is it?
well, for the second one, I got 38.
Mighty God. What's your answer, Michaela?
37.
What are something? Anybody else? Anybody else? Mariana, Alana,
38.
50. Why are you guys
38. 38.
38?
Mrs. Sonrang.
What about you, Alana? Do you
Miss,
have the
sorry,
same
not
thing?
37, 38, sorry.
Okay. All right, so everybody's wrong. Oh my gosh.
Miss, how is it?
All right, so remember I said that the order, so you have to look at the order, right? Let's look at the order. Let me get the pen. So we have a 3x1 matrix, correct? This is
Yes,
3 by
miss.
1 in a 1 row, 2 rows, 3 rows. And then this is just 1 row, but 3 columns. So that's a 1x3. 1x3. So because these two numbers here in the middle are the same, it means that yes, they are compatible. They can be multiplied. And then remember these two n numbers combined tell you what kind of matrix you should get. So that's a 3x3 matrix. That's the matrix. So everybody's giving me 1 digit. Well, not 1 digit, but 1 number. 38. But it should be a 3x3 matrix. So let us look at it. Let us, so we have 1, 2, 3. And then we have 5, 6, 7. So row 1, row 2, and we have row 3. Hold on. Yeah, so as I said, it should be a 3x3. Your answer should be
I
a
see it now, miss.
3x3 matrix. If you observe, 1 row, 1 row, 1 row. So each row has 1 and each column has 1. That's what is happening. So there is no addition that's going to take place. Row 1 is 1 multiplied by the first element, which is the only element in column 1. So that's just going to be 1 times 5. Then row 2, and you can just finish off row 1. So that's row 1, column 1. Then row 1, column 2 is going to be 1 times 6. And then row 1, column 3 is, so once you go to a different column, you cannot be adding. Once you move on to a different column, you cannot be adding. You have to be multiplying again. So it's gonna be 1 times 7. Let's see it now, though. Then we go to the next row, which only has 2 in it. So it's gonna be 2 times 5. Then 2 times 6. Then 2. Why do we keep on using 2? Because we're still in row 2. So once you're in row 2, you're multiplying by the element in row 2. Each time you go to a different column, you multiply by the number in that column. So we're still in row 2, so everything is being multiplied by 2 because it's 2 that is in row 2. So 2 times 7. In row 3, the element is 3. So we're in column 1, so we're multiplying by 5. Then we go to column 2, so we're now multiplying 3 by 6. Column 3, we're multiplying 3 by the 7. So we're going to end up with 5, 10, 15. And then we're going to have 6, 12, 18. And then we're going to have 7, 14, 21. And there we have it. We now have a 3 by 3 matrix. Look at it. Row 1, row 2, row 3. Column 1, column 2, column 3. We have the 3 by 3 matrix. And this is our answer.
Yay!
So this
Miss,
what
it make it look so difficult, and the fact it's pretty easy.
me make it look difficult. Me.
Miss, the question make it look so difficult.
No, it's
Yeah,
how
miss, when you set it out, I realize what I did wrong.
yeah. So you're looking at what is in the row, what is in the column. So once it's one element in the row and one in the column, there's no addition. It just once you multiply those two numbers, row and column, you finish with that spot. You're moving on to the next one. Yeah, so to concrete it, let me give you one more.
Miss, I don't like when you smile about it because I feel like the last time
You
you
don't want me to
smile,
smile? That is not
you
good.
smile when you're giving us this, it to me it was difficult.
I can't believe you're saying you don't like when I smile.
Miss, I love when you smile, but sometimes your smile is mischievous.
I mean, for the C-Tech level, it doesn't really get any harder than this. And it's mainly 2 by 2 matrix that you have to deal with. Trust me, I did a whole course in college on matrices. It is vast. So C-Set just give you a little snippet of it. Just a little snippet. All right, so let me give you one just like this. No, not just like it, but similar. Just to cement, just to check if you get the idea of it. What's the order of the first matrix?
4 by 1. Wait. No, miss, 1 by 4.
Miss,
Hey, Jalil, you need to work on the confidence, you know. All right, so you see, I think it's legit. When you actually know something, like you actually know it, it's not that you're seeing it for the first time. When you know something, and then you're tested on it, the right answer normally comes to you first. And then after that, doubt come in and you change to the wrong answer. That's usually what happens. So you gave me 4 by 1, which is correct because it is 4 rows and 1 column, and rows must come first. Remember that rows must be first, right? So it's 4 rows, 1 column, so it's a 4 by 1 matrix. And the second one is a what's the order of the second matrix?
1
1 by
by
4.
4.
1 by 4. So it's 1 row and 4 columns. So then we see that the two numbers in the middle are the same. What kind of a matrix should you end up with for your answer?
A 4 by 4
A
matrix.
4 by 4.
4 by 4.
A 4 by 4 matrix. As simple as it sounds, I still want you to do it so your brain does it. Go ahead and do it. So we're not adding the numbers because your shift, each time we shift to a new column. So there's only, so if you have 2 elements in the row, this is for the persons who were absent. Let's say you have 2, 4, 3, 1. When you separate the rows, you would have these 2 elements in the 1 row and these 2 elements in the 1 column. So because they're coming from the same place, same row, same column, you have to add them because it's gonna be truncated to 1 element for that spot. But now you only have this 1 element there and this 1 in the column. When you finish with that, you're finished with that row and that column. So you wouldn't have anything to add because you would move on to a next column. Once you move on to the next column, that means you're finished with the other one, so you wouldn't be adding anything. I hope that I answered your question and didn't make it complicated. Let me know in the chat. Yes, Michaela?
Miss, I'm finished.
Oh. Okay.
I'm also finished.
All right, so we're waiting 2 minutes on the others. All right, so Michaela and Jalil is finished. Is anybody else finished? All right, so let me erase this. Outside of Jalil, anybody else want to write on the screen?
Me, miss.
Okay, Michaela, go ahead.
Miss, so we're doing this, right?
Yeah.
Okay, so I don't have to write that out.
No.
I'm finished.
Great. So we have Michaela doing it on the screen for us to see if we're all learning. 4 times 1 programs.
Miss, I'm finished.
Okay, thank you. Is that what everybody got? Um,
Yes, miss. That's what I got.
Yes, miss. Yes, miss.
Wonderful. Wonderful. Anybody didn't get it right? Yes, Alana, did you put something in the chat? See your hand raised. I know you have sound issue. I'm responding to someone in the chat, guys. Michaela, your numbers were so close, you confused the student. At first, I thought this was 48, you know.
I'm so sorry.
And then I realized, oh, it's just too close.
Sorry about that.
Yeah. All right, so everybody got it right then. Assuming the persons who responded did. All right, so you're gonna get more assignment on multiplication because you know you need to practice. That's later. So we're gonna move on now to, yes, Michaela.
I was going to ask, if I should erase that. But never mind.
All right, so the next thing that we're gonna be looking at, and we had to do multiplication first because it can include multiplication, is equal matrices. The two matrices are said to be equal if and only if, one, they are of the same order, meaning the same number of rows and the same number of columns, and each pair of corresponding elements are the same. So for example, or in general, if you're given a matrix A with elements A, B, C, D, and a matrix B with elements E, F, G, H, then if the two matrices are equal, that should mean that A is equal to E, corresponding elements are equal. That would mean that B is equal to F, C is equal to G, and D is equal to H. So elements in corresponding positions must be equal if we are claiming that the two matrices are equal. Seem okay so far? You know, they always start off easy.
Yes, yes.
One moment. Michaela, your hand is raised.
Yes, miss. Could you go back to the slide for just 1 second, please?
Sure, it's just 1 second.
All right, give me 1 minute.
Okay. All right, all right.
Okay, miss. Thank you.
Okay. Right. So here's an example. So it says, given that x, -3, 4, y is equal to -2, -3, 4, 6, determine the values of x and y. So what's the value of x based on the definition that we just looked at a while ago?
-2.
-2.
Beautiful. So the elements it is stated with the equal sign that the two matrices are equal. So that means the elements in the corresponding positions are equal. So x is equal to -2 and y is equal to
6.
6.
wonderful 6. All right, so as I said, that's how it starts off easy. What happened? Oh, wait. What you crying for? Right, so I think I have the question on another screen. Hold on. Whiteboard. All right, so let's look at a question that is not so straightforward on equal matrices. You see in the screen, right?
Yes, yes.
Yes, miss.
And we're gonna look at number one. It says, given that A is equal to -1, x, y, 2, and B is equal to 2, -1, 1, 3, and C is equal to all of that, and AB is equal to half C, calculate the values of X, Y, P, and Q. How would you approach this question? What's the first thing you would do in approaching this question?
Miss, the first thing we would do is find out what give it 20 and 12.
But how would
And
we
it
do that?
can this by finding the what and what give it 20 and what give us 12. I think.
All right, so the question says AB is equal to half C. So that actually means that they want you to multiply the matrix A by the matrix B. So that's the first thing that you have to do. So that's the first thing that I'm going to ask you to do. Do the multiplication. You find the value of X and Y.
Miss, repeat.
So it says AB, which means A multiplied by B, is equal to half C. So you need to multiply the matrix A by the matrix B. That's the first step. Yeah, I just remember that you're in pain. All right, so I want you to do that for me. Multiply A by B. Give me a minute. I am back.
Excuse me, miss.
Yeah.
So after we multiply A and B, we should do C after?
You should do half C because it says AB is equal to half C. So you have to do AB and you have to work out half C. All right, what's your answer for AB? Let's see if everybody's on the same path.
Miss, my answer for AB is 5x, 2x, 3xy, and 0.
I'm gonna write it down. 5x, 2x over here,
Yes, miss, 2x.
and
3xy.
3xy, and 0.
No, 3yx, sorry.
X, Y, Y, X would be the same thing.
Okay, and 0, yes.
Anybody with a different answer for AB? Gosh, just Papa. All right, so it's row times column. So it's going to be -1 times 2 plus x times 1. And then we're going to have -1 times -1 plus x times 3. Then I go to the next row, y times 2 plus 2 times 1. Over here we have y times -1 plus 2 times 3. Simplifying that, we get -2 plus x, because x times 1 is x, 2y plus 2. Then on the other side, we have negative times negative positive, so 1 plus 3x, and y, negative y, plus 6. Anybody got that for their AB?
Yes, miss.
Wonderful. All right, so that's AB. Only Jellin responded. Remember, if you have any questions, you can raise your hand, ask a question, or write it in the chat. Then now they said AB is equal to half C, so we need to also find half C. And half C is scalar multiplication, right? So for those who were absent, scalar multiplication is when you multiply each element in the matrix by the same number. So half C means that we're multiplying each of the elements in C by half. And multiplication by a half is the same as division by 2. Forgive me for being lazy for 1 second. Half C, C up here, right? 2p. What is half of 2p?
1p.
1p.
1p. So we're gonna have p right there. What is half of 20?
10.
10.
We're gonna have 10 right there. And then half of 12 is 6.
6.
6.
And half of 2q is
1q.
1q.
Miss,
Right, so yeah.
question.
Mm-hmm.
For
Right.
A and B, what did I do wrong?
You would have to send me a picture of what you did.
Okay.
Because what we have right here and what you said are not related. So you would have to send me a picture.
Definitely not related.
Uh-oh. Let me write that back. That's times 3, close the bracket. All right, so once again, the question says AB is equal to half C. So we worked out AB right here and we got this. So what we're going to do now is equate the two answers. Hmm? No, you cannot write. AB is equal to half C. And we got -1 plus 3x. Not 3x, x. All right, somebody has to write for me. My son got vaccinated and yeah, he's miserable. So somebody write the matrix AB for me. -1 plus x. I have 3x right here. That should be -1 plus, oh, it's not 1. It's -2 or something, right, bud? I need to fix that. Because this is -1 times 2, so that would be -2. So this should be it, -2. -2.
I'm not in the whiteboard, miss.
Huh? Oh,
I'm not in the.
oh, I can share the link for the whiteboard. This is not Zoom whiteboard, that's why. Hold on. Share link. I tend to prefer this whiteboard more than the Zoom one. That's what the link long. All right, so you can join the whiteboard using that link. Oh, so Zoom change up now if you don't join the whiteboard, you cannot write. Yeah, so you can erase what I have in the bracket right there. Should be -2 plus x. You're gonna equate the two answers. So that's AB, and it's equal to half C. Half C is P, 10, 6, Q. Then now we equate corresponding parts. So -2 plus x is equal to p.
Miss, I have a question.
Go ahead.
Beside the -2, that's a plus sign,
Yeah.
and the 4, it's 43, right?
No, it's 1 plus 3. 1
Oh.
plus 3x. One plus I think we're gonna get simultaneous equation from this one. -2 plus x equals p 2y Mhm. 2y plus 2 equals 6. And over here we have 1 plus 3x equals 10. And so everything don't need to be solved. Well, let's write it out. -y plus 6 equals q. So we have to find based on what we have, we can find x and y first. 1 plus 3x equals 10. This is a simple equation to solve. How do we solve this equation?
By carrying the one over to the other side and change it to a negative.
So we're gonna move the 1 first, transpose. So we're gonna have 3x equals 10 minus 1, which is 9. So 3x is equal to 9. And what do we do to get x?
Divide each side by 3.
Beautiful. Beautiful. So 3x equals 9. But we don't want 3x, we want x. So we divide both sides by 3. 3 is cancelled over there. X is equal to. So this is a long question. Might be worth 6 marks maximum. So we've just found x. Then now to find y, we would use this one. 2y plus 2 equals 6. So we would transfer the 2 first. 2y equals 6 minus 2. Once you transfer from one side of the equal sign to the other side, you do the opposite. So it was +2, so it becomes -2. So 2y equals 4. And we want y, so we divide both sides by 2. So y is equal to 2. So now we have x and y. So now that we have x and y, we can find p and q. Based on what we have, p is equal to -2 plus x. So I just spin around what we have right here. -2 plus x equal p equal -2 plus x, same thing. Nothing was changed about it. -2. And we know what x is. X is 3. So we're gonna say p is equal to -2 plus 3. And that is 1. And then the last part, we want q. We're gonna say q is equal to -y plus 6. And we know what y is. Y is 2. So that's -2 plus 6. And the -2 plus 6 is 4. So we have x equal 3, y equal 2, p equal 1, and q equal 4. That was a very long one to digest.
Miss,
Yeah.
my Wi-Fi cut out, so I got disconnected. And I recently came back.
So we just went through a long process.
Very long.
It's in the recording, right? So I'll just watch the recording.
Yeah, I think what I'll do, I'm gonna post the recording, but I might actually, because my son was, crying, I might do a mini video just going through the question by itself as well.
All right, miss.
All right, based on the long process that we went through a while ago, though, guys, anybody with a question, any part of it that you processed that you want to ask a question on?
Miss, repeat.
I'm saying based on all that we went through a while ago, any part of it that you processed that you want to ask a question on?
No, miss, because I figure out how to do the AB.
Okay. All right, so what I'm going to do, there's 15 minutes left in the class. I'm not really want to stress you anymore. I'm going to make another video with two examples, right? This one and another one. And we're going to look at the determinant of a matrix.
Alright.
Which is something, a simple concept. A much simpler concept. Somebody asked me to small up the screen. I hope it's not too small. Mariana, I can move on.
Yes, Miss, you can.
Okay. Right.
Miss, 1 minute.
1 minute on the screen.
No, Miss, something I want to ask.
Okay, go ahead.
Over to B, where you see 2, -1, and 1, that's a 3, right?
Over to B, 2, -1.
1 and
Yeah,
3.
that's a 3.
Okay. Good to go.
Okay. You want to sit down? You want to sit down? All right, the determinant of a matrix. Given a 2 by 2 matrix A, the determinant of the matrix is the product of the leading diagonal elements minus the product of the non-leading diagonal elements. So let's say the matrix has A, B, C, D, then the determinant, and this symbol right here, the 2 lines at the side, represent size or magnitude or determinant in this case. So it's going to be the product of the leading diagonal, which is AD, meaning A times D, minus the product of the non-leading, which is BC, so minus BC. And we want to put that into action with an example or 2 or 3. So, and we usually, well, at this stage, you're only finding the determinant of a 2 by 2 matrix. So find the determinant of this matrix for me. That's matrix A. So if we're finding the determinant of this matrix, then we would write the line A, the line. Can use bracket 5 times 2 So this is the leading diagonal minus the non-leading, which is 4 times 3. So 5 times 2 is 10. 4 times 3 is 12. So that's 10 minus 12, which is -2. So the determinant of this matrix A would simply be -2. Any question?
No, no.
All right. So find the determinant of the matrix B if B is 1 to me a 5. Yeah, I don't want to use 5. -7, 1, 3, 2. Let's make that -3. Find the determinant of matrix B for me. Yes, Jalil?
It's -17.
-7 is your answer.
17.
17.
17 as well. -17 as well.
Okay, so everybody got -17. Beautiful. Let me see if your maths is mathsing. So that's -14 minus -3. See, a good honest. You guys realize that this is -3? Confirm for me.
No, miss.
No, it's like this.
All right. All right, so it's 3. That's what you have, right? 3?
Yes,
Yes,
miss.
miss.
Okay, we'll work with that. So it's gonna be -14. Oh yeah. -3, which would be -17. Ready for telling so wrong and but on the right. Wonderful, wonderful. All right, so that is where we're going to end today. So I'm going to send you an activity. Give me a little time to post the video, the recording, and the 2 videos at the end of the night and the activity. It's gonna be a short activity because determinant is easy. But as I said, any topic that is easy, you need to practice. Because if it's easy to remember, it might be easy to forget as well. All right, so I'm going to send you some more practice on determinant and try to find an easier question for equal matrices for you. But I'm also going to find the CSEC questions as well. All right, so that's it for today. Class will be at 11 tomorrow, God's willing.
Okay, miss.
Have a good day.
All right, miss.
Bye.
Goodbye,
Bye.
miss.
See you tomorrow.
Okay.
Adios.
Adios, au revoir.